to do the initial job, start to test some different materials as my sample. So here as the real experiment in mind, I use some different media. First one is a solid, and then I put some mouthwash and then toothpaste to do different tests and try to compare the result and find out maybe I can find some process signals. So here I just show you solid with mouthwash as the intermediate. So this is the result. RGB, yes, you still can see green line is the most intensity of this result. So, and compared to toothpaste and what mouthwash, I find that you can see the signal with mouthwash is smaller than the signal with toothpaste. And I assume that the mouthwash can eliminate bacteria in our mouth. So when I put mouthwash with solvent, the bacteria is fewer than the other one. So basically, the process should be smaller, so the signal will be smaller than the other one. And this is the curve. You can see the solid line represent the toothpaste cure, and the dotted line represent mouthwash cure. Of course, you can see with mouthwash the signal is smaller because I assume the bacteria is smaller, so the process signal is smaller. Yes, so this is what I have. I mean, score result. I have many of it, so I just capture some of them. And finally, you can see that RGB still, we can see green line is most. And from 1 centimeter to 4 centimeter, it decreased. So, yes, green line first, and then blue line, blue color, and red. So I try to analyze it. So you can see that if I use this pie chart, basically, if the three color bands is, I mean the contribution is very pale. The center point should be located here, but now we have different contributions. So the green line is the most, then blue color, then the red color. So finally we will find a new center point. So yeah, so here is the mathematical algorithm to analyze this. We can find the Q, saturation, and lightness. Basically, the Q means this angle. It related to the color, which color is the most, and saturation is represent the amount of chromaticity, and the lightness is the strength of the colors. So yes, sorry, I just give you the future. I will not say the future how to improve it, because I've said that process like this not difficult to detect. So I find a solution if I can use a PMT to amplify the fluorescence. They use the mirror to refract the photon many times, so they can enhance the process. This is just a plan, but I hope it will can be improved, can be used to improve the test. So concluding, well, we can see group color is always the most in RGB color bands, even process test or soluble test. And yes, mouthwash is better than toothpaste to kill bacteria. And of course, well, process light too tiny. If I can amplify it, and much it's easier to collect data. So yes, questions.
Okay. I'm not convinced that you see a difference between the bacteria when you take it from the saliva and then bacteria from saliva when you use mouthwash. You didn't convince me in your presentation that
yes,
that difference exists.
Yes, I have this data and this result.
But where is it in your presentation?
Okay, when I start to do these slides, I just think which one is better to be chosen in its because I need to compare toothpaste and mouthwash, so I just pick up these two data. And if you need to know more,
well, if you go back to the HS diagram.
okay. Yeah.
You've essentially got one data point on that, which is the white spot in the middle. Why didn't you have the other points on that? Because, you know, that would have convinced me. I'm not convinced at the moment that you've reached the end of your project.
I just try to explain when I test my YLED, I'll find this new set.
But that's the important point. That's the most important diagram in your project. All you think about the transistor is not very good. That embodies your project. That sums up your project. And you've missed putting those points on.
Yes,
I've seen them, but the audience haven't.
Okay, yes.
Okay.
Sorry about it.
Okay. Now, it's interesting you're talking about future work, and you're talking about using the photomultiplier tube. Can you think of a disadvantage why you shouldn't use a photomultiplier tube?
Well, at this time, I haven't had much time or much money to support me to do this.
It's not about money. But why shouldn't you use a photomultiplier tube? Bear in mind you're going to take this device and put it close to someone's mouth. So why wouldn't you use a photomultiplier tube?
I know, but well, normally we will take the sample out, and maybe we need
No,
time.
No, we're going to actually use it on someone's
I know.
So why wouldn't you use a photomultiplier tube?
But if we cannot detect it at one time, I mean.
Yeah, but the question is, why would you not use a photomultiplier tube?
Well, it's still the time limit because.
No, forget about the time limit.
Yes, I spent a lot of time to do the previous work. I mean, I test the process, I test a lot.
You're avoiding answering a question. You introduced in your slide that the future work, and you must have thought through it, which is, you know, quite a good thing to do. You've decided to use a photomultiplier tube, and you're going to put this next to someone's mouth. Why is it dangerous to do that?
I don't think it's a good idea because
why?
I can expect what will happen if I put a device just point.
Okay, what will happen?
Actually, I don't know.
Okay. I can tell you a photomultiplier tube uses high voltage to make it work.
Yeah.
So you're going to need several hundred volts. And if anyone brought 200 or 300 volts in their mind now, I would tell them no.
Okay.
So that's not a practical solution. Okay. But you've got plenty of sensitivity in the diode system that you're using because you've got a result from it. Okay? So all you need to do is enhance the gain and reduce the noise. I think that would be the most sensible way to do it.
Thanks.
Okay. Does anyone else have any questions? I don't see why I should ask all the questions. Anyone?
When you pass on.
Yeah, go on.
So, can you tell me you using? Can you tell me other methods to detection the bacteria? And what's the main advantage of this method you use?
Well, I believe there are many solutions to do this test, but
Why did you choose this method?
well, it's simple, easier, and in this
So have you done any surveys about other kinds of
yes,
methods?
of course, but some solutions too complicated, or I have to choose a safe method for me to complete it in these 3 months. So this one should be better.
So the rocket, what does HSL means?
Hue, saturation, and lightness. Hue, it's related to the color bands.
Oh.
So yes, so
you
if the green, I can show you.
Okay, you better give some simple definitions before you use it.
Yeah,
So
I'll mention it in my thesis. So if you are interested.
okay, thank you.
Yes.
Okay, just to give you some feedback, okay, a presentation is all about communication, okay, and I think the last question actually points that out. You didn't explain to people what HLS was.
I did.
You think you did, but you didn't.
No,
Okay.
Sorry.
It's all about communication, but you spent an awful lot of time on the detailed electronics,
Yes.
which to me was not useful, was not helpful. All that you did was you drove the LED with the current, stabilized current, and that would be insufficient. And then you had a detection circuit which detected the signal. One of the most important things was the processing of that signal, and you needed to give an introduction to that. Okay. I think very few people around here will know what HLS actually means. So you needed to do the introduction. So it's all about communication. Okay.
Thanks.
Okay. Good. Okay. Can we have our next speaker? Sorry. Sorry. Yeah. I just tend to dwell on the negative points that I think it's important.